Hey students, we're going to take a look at trig identities with multiple angles. That means things like cosine of 4 theta instead of cosine of theta. That makes this a little bit harder for us to work with, and I'm going to start kind of visually with how these are different, and I hope that kind of makes some more sense once we get into the math of it. So I've graphed both sine of theta and sine of x and sine of 4x here. And what I've done is I've put in a horizontal line that's at a height of 1/2. What I'd like us to notice is that for sine of x, we get our two predictable answers at pi over 6 and 5 pi over 6. Both of those have a height of 1/2. For sine of 4x, suddenly we have 1, 2, 3, 4, 5, and there's a sixth answer that I obviously skipped for the first one. So we've got 6 different answers that seem to fit within this same interval, and in fact I'm covering up some other ones, but I can't move those things around. So there would be a 7th and an 8th here and here, and what we end up finding is that there are 4 times as many answers as there were originally. And that might make sense because we're going 4 times as fast through this problem and through this graph. So as we do that, we hit these heights 4 times instead of 2 times. So let's look at what this looks like in terms of doing the algebra for this. I'm going to go through this doing a way that makes some sense to me in terms of getting solutions without doing too much crazy thinking involved here. The first thing I've got to do is figure out what my 2 normal solutions would be. So I'm going to call this kind of the original problem solutions. And in looking at that, we're going to have heights of 1/2. So we've got 5 pi over 6, and we've got pi over 6. Those are both equal to 4x. And in solving those, we get x equals 5 pi over 24. And we've got x is equal to pi over 24. We know that normally we could add 2 pi to each of these going around in order to get to our next solution. When we're going around 4 times as fast, what we can do is say, okay, well, 4x is equal to 2 pi, and I'm going to solve for x, and we get x is equal to pi over 2. For the sake of making the calculations easier, I'm going to convert this into 12 pi over 24 because both of my answers are in terms of 24. What's going to happen here is I'm going to add this to each of our answers repeatedly until I get to an x that's over 2 pi. That sounds a little bit confusing, so let's kind of set this up. So we got 5 pi over 24. And to that I'm going to add 12 pi over 24. And that gets us from 5 pi over 24 to 17 pi over 24. Okay, we're still okay. I'm going to start at 17 pi, and I'm going to add that again. And we end up with that getting to 39 pi over 24. We're going to start that again. So we get 39 pi over 24 plus another 12 pi over 24. And when I do that, I've got, it's 40, 51. And as soon as I do that, I'm now over 2 pi, so we cannot use that one. Okay, I'm now going to do this for the other set of values here. Starting with pi over 24. We're going to add 12 pi over 24, and we get 13 pi over 24. We're going to do the same thing, and when I do that, that's going to give me 33, and I totally lied there. That's going to give me, oh man, I'm going to go back and fix the other ones that I added wrong in just a minute. That's going to give me 25 pi over 24. And then I'm going to get to 37 pi over 24. If I tried to do this again, I get 49 pi over 24, which does not work. So we've got 4 answers on the blue side. I'm going to go back and fix my purple side because I really messed that one up. Starting with here, because I added and should have gotten 29 and got 39 instead. What that means is that I can add another one and we get 41 pi over 24. The next one would take me to 53 pi over 24, but that one is too big. So the answers for this are going to be 5 pi over 24, 17 pi over 24, 29 pi over 24, 41 pi over 24, pi over 24, 13 pi over 24, 25 pi over 24, and 37 pi over 24. And the good news that I have for you is that we are not generally going to be dealing with an angle that's 4x because of this. We get this mess of a thing where we have all of these pieces that we then have to double and triple and quadruple check. More likely we're going to see ones that are like, oh look, we've got cosine of 2 times an angle. I bet that means we're going to get twice as many possible answers. But hey, that's better than 4 times. All right, we've also got an 8 out front, so let's get rid of that 8. And we've got cosine of 2 theta is equal to root 2 over 2. We know that happens at pi over 4 and 7 pi over 4. So let's have 2 theta is equal to pi over 4, and 2 theta is equal to 7 pi over 4. I'm also going to say 2 theta is equal to 2 pi because that's 1 period of our cosine. We divide that by 2, we see that we're going to add pi each time. All right, finishing up the other problems, I'm going to divide by 2. We get theta is pi over 8, and theta is 7 pi over 8. Since these are in eighths, I'm going to rewrite pi as 8 pi over 8. So I'm going to keep going and stop when I get to 2 pi. So I'm going to add pi over 8 plus 8 pi over 8. That gets me 9 pi over 8. I'm going to try again. That would get me 17 pi over 8, but that's too big, so we stop. At 7 pi over 8, I'm going to add 8 pi over 8 to get 15 pi over 8. When I add again, we get 23 pi over 8, and that's too big, so we stop. My answers are 9 pi over 8, 15 pi over 8, 7 pi over 8, and pi over 8. For our last one, we're going to solve this guy, and I might do some simplifying first. Divide by both of these pieces by 2, we get negative 3 minus root 3 over 2 is equal to negative 3 plus sine of 3 theta. I notice I've got negative 3 on both sides, so we're looking for where sine of 3 theta is negative root 3 over 2. That happens at 4 pi over 3 and 5 pi over 3. So if we've got 4 pi over 3 is equal to sine of, just 3 theta. I don't know why I wrote sine again, and now it won't erase. There we go. Is equal to just 3 theta, and 5 pi over 3 is equal to 3 theta. That gives me 4 pi over 9 and 5 pi over 9. I know that I've got to do 2 pi is equal to 3 theta. That gives me 2 pi over 3 is going to be my new period. And it might be useful, again, to put this in terms of 9. So we multiply that by 3 over 3, and that gives me 6 pi over 9. So that's what I'm going to be adding each time. Again, my goal is when I get to 2 pi, I'm going to stop. So for 4 pi over 9 plus 6 pi over 9, that's going to be 10 pi over 9. I'm going to add another 6 pi over 9. It's going to be 16 pi over 9. I'm going to add another one, 22 pi over 9, and that's where we stop because that's bigger than 2. From 5, we've got 11 pi over 9. I've got 17 pi over 9, and when I add another one, 23 pi over 9, but that's too big. my 6 answers, and again, we had 3 times what would normally be 2 answers, and we got 6. 4 pi over 9, 5 pi over 9, 10 pi over 9, 11 pi over 9, 16 pi over 9, and 17 pi over 9.